Okay. So the performance final is what you could say is equivalent to what like an essay would be in another subject area. So part of it is being able to perform. That's why hence performance exam. But another part of it is be able to justify and explain what you've done. Use reasoning. You're having deja vu all over again? I swear. All right, so the first one says solve one of the following systems, but actually we're going to solve both. We're going to solve both the systems by we'll solve one by substitution and one by elimination, but then we also have to explain why you chose the method you use for each. Part of you will be scored on a rubric, and part of that rubric includes your ability to justify what you've done. In order to get full credit, you also have to be able to explain. So let's look at the first one on the left. What would you say is the best method to solve that system? Elimination. I agree with elimination, but that's just part of it. You have to tell me why you picked elimination. Because there's why. Huh? Remember, there's a rubric, so I mean, if you say y is not by itself, maybe I'll throw you a point or something like that, just for fun. But that's not complete and concise. Yes, sir. Oh, look at that. So you could say both equations are in standard form. And that would get you some more points, but that also probably wouldn't get you the complete amount for justification, because there's also some other benefits that lend itself to elimination. And that's that the y's have the same coefficient and different signs. Because all that put together, well, that looks like it says days, but it doesn't say days. I meant to say the y's. Hope gets it. Jonathan gets it too, kind of. Where's your paper, man? Oh, can't see, sorry. Dollars.
Okay, sorry.
You ruined it.
I ruined
it. For everyone. No one's life will ever be the same again. Thanks a lot, Elsie. All right, so now we're ready to go ahead and perform what we said we were going to perform, which is elimination. And we're going to eliminate the y's. But when we eliminate, what are we actually doing? No. It's elimination by. Good, elimination by addition. So add her order. It's at the candy store. What elimination accomplishes for us. That makes it okay. What elimination accomplishes is that we go from two variables down to one. So now we can solve for x. X is -5. But we all.
Mañana va a ser así. Mañana va a ser así.
So hopefully you realize that we're not done yet, because in the system we're looking for an intersection, and all we found so far is the x of that intersection. We're still missing the y. In order to find the y, we're going to substitute, and we can do so into either equation. If you do it correctly, you can go into either equation. But if we have x already, that means we're looking for y. What do each of those y's have? How are they different from each other? What do they not have in common? Huh? Yeah, one has a positive in front, one has a negative. If I were you, I would try to avoid that negative like the plague because you guys always, that's just one more thing that could go wrong. So I would stick to the y that's positive. But that's not because you have to. It's not a mandate. It's just a recommendation. -4, not times x, but times -5 because I just found x. Plus that y that I'm looking for is equal to 26. I just wrote the first equation, but I took out the x and replaced it with a -5, and by doing so, that only leaves me one variable, so I can solve like they do in the hood. -20, so y is equal to 6. But then if you want a super duper perfect score, you would also indicate to me that you understand that this is an intersection, and these are where two lines are crossing. So how can this solution be expressed? Go away in our Wayback Machine to systems of equations. How did I express the solution each time? Yeah, what do you call that? An ordered pair, very good. Where the order is alphabetical order. -5, 6. Alright, so if we use the elimination for the first one, the directions state that we're gonna have to use substitution. What? We're gonna have to use substitution for the second one. Oh no, can't spell. But we have to justify it, and our justification cannot just be, well, I used elimination for the last one, so I'm doing substitution because the directions told me to. Oh yeah.
It's because they're not both in the same form.
I don't care about that.
One is isolated.
Well, there we go. One variable has to be isolated. It doesn't have to be the y, but in this case, the y on top is already isolated. I'm not going to grade you really on grammar. I realize that for some of you, English is not your first language, or in some cases, even your second language.
I can hear you right. Alright, you right. I can hear it.
So does your face.
Ooh.
You need some aloe for that burn.
What?
Um,
Aloe, like aloe. You said in your face. No, I was talking about like because you're loud.
I couldn't get that joke either.
You guys are so
funny. No, it just wasn't funny.
You know what? Don't bully Mr. Romero like that. You want to keep doing this at a sequel to you.
Hey, wait, I'm finishing. He comes from the state.
Yeah,
but it's supposed to be on our side.
Alright, finished? So because we have a variable that's already isolated, that means that we can already jump right into substitution. Since the top y is equal to x minus 11, I can then write the bottom equation. But once I get to the y, I won't write the y, I'll write x minus 11. And even though I didn't physically actually eliminate, what have I accomplished via substitution? What has substitution accomplished for me?
Nothing.
Nothing, because school is boring and I can get more accomplished by having conversations while the teacher's talking than I can by paying attention.
It's already equal to what?
What have I accomplished by substituting?
One variable.
Yes, I'm down to one variable. Now that I'm only down to x's I can solve. So first I would distribute. And then we combine like terms, like LC loves to do. No, this is my happy face. 6x is equal to 36 divided by 6. So this confirms to me that the two lines will indeed intersect, and I have the x of that intersection, but I'm missing the y. No, there is going to be a y, and I'm going to find it. And not only am I going to find it, it should be much more quick and efficient to find, because one of the nice things about substitution, Elizabeth G. Fuel, is that when you use substitution at the beginning, there should be, when you're looking for the other variable, there should be an equation that has that variable already isolated for you. I'm looking for y. Now, because I have to, but if I want to save time, that top equation is looking mighty nice, because I can just say y equals 6 minus 11.
Yes, sir.
How do you do that? Wait, don't feel normal.
And what's the ordered pair of this solution?
You let your
How do you do it?
6 combinator 5.
I'm not a very good teacher.
No, it's not important for teacher. People just don't choose the lesson. That's exactly it.
I just looked at
I think it's Emma's fault.
No, that's so crazy. No, you teach them people that don't pay attention and they try to blame us.
Yo no sé, yo no sé, yo no sé. No sé. Hi, Soha. All right, good. Any questions, number one?
Yeah. What?
Okay, so now let's move on to number two. Define domain and range.
Domain is X.
Well, yeah, so again, I'm not going to grade you so much on grammar, but in order to be able to get the maximum amount of allotted points, I'm going to look for keywords. So here are some keywords that we use. Definitely for both of these, I want to see the word set. Domain is a set of numbers, so is range. Okay, somebody said for domain X, sure. Put the set of all X's. Some other words that you could use in exchange for in exchange of X's that would be fine is set of all inputs, set of all independent variables. Earlier on when we did functions, I gave you some words. What you just talking about people not paying attention? Guilty as charged.
I'm not blaming on you.
I placed myself at the mercy of the court.
You never said you were bad.
No, but you said you were talking about kids don't pay attention.
Because they blame it on you. Think
So
you're bad.
practice what you preach and just pay attention.
That's a fun. It's a classroom, not yours.
Okay, it's gonna
I'll just write Emma up because it's Emma's fault. She's bad at this. Emma's like the Meg Griffin of the classroom. So I since we conveniently keep all of our notes in one place,
Yes.
you can go back and look when we first introduced functions. There's a variety of words that can also imply X. So if you use any of those words, that would be fine. So the set of all X's in a relation. Function could be an okay word, but function will not give you the maximum amount of points because every function is a relation, but not every relation is a function. That's when we learned about function tests and vertical line tests. Huh? This is where you failed math on functions? I think it's Emma's fault. So then therefore the range would be the set of all y's. There's also some other words like dependent variable output. Set of all y's in a relation.
First of all, we have to define. Come on, man.
Well,
The same language.
you might have to define anything, but if I'm going over this today, I would assume that this would be the main thing you want to focus on.
Okay.
So, Okay, part B asks you now to create your own function. So this is not just a relation. The points that you put here, have to be able to also pass a function test. The easy, most watered down way I can explain this to you is make sure the x's don't repeat. Other than that, you have carte blanche to pick whatever numbers you want.
Do you see this, Mr. Moon? I'm actually taking notes.
Or are the notes taking you?
I just ruined it.
You're not part of the originals.
You're not part of the original.
Yes, I am. Ask him and Elsie.
You're so funny, 5 minutes.
Why is it a function?
Why is it a function? Because Nick, I'm glad you asked because that's the next question.
Exactly.
It says, explain why this is a function.
It doesn't work. You actually don't work.
Guys, can we do this real quick? I mean, the test is legit tomorrow, and I really want to review for this. I don't want to fail. Can we go over this, please?
Nick, school is not for learning. It's for friends
Hey,
and
if
fun
you want to learn
and
this stuff, watch
food.
this video later.
If you want to learn, go home.
Well, if you keep on, I'm not going to finish the video. So explain why this is a function. In between all the nonsense, I heard some people talking about that the x's don't repeat, which is fine, but that's kind of an elementary type explanation. I'd probably give you most of the points for that, but not all of them. A better way, I would like to see again those key words like input, output. Notice how they even used input, output. Even if you were to use x's and y's, that's fine. But you would say each input has exactly one output.
Why am I so rude?
Did I tell you to go over in that jacket yesterday? I could just.
Oh, it's his sister. I saw it too.
That's weird.
Alabama. Bro. Oh my god.
You guys should have like a study session this weekend, and then you can have all the side talk and stuff. That'd be cool. Okay, the last one, identify the domain and range of the function. This answer to D will be contingent, on if this were to be something you were to get on the performance test, that would be contingent on what you put for B. So for the domain, let's make sure that the domain is whatever you put on the inputs. I just happen to put those numbers. You don't have to pick the same numbers. But whatever numbers you put for the input, that would be your domain. And El Rango would be whatever you put for y's. You want to share Hope's chewing gum?
That's so weird.
Her ABC gum? What does ABC stand for?
Apple, banana, and coconut.
Already been chewed.
Do you like coconut cake?
You like carrot cake?
Oh, just math.
I can make you fried chicken.
Right.
Yes, sir. That's right.
When's your birthday?
Yeah, you
February 30th.
do. That is weird.
February.
There's no such thing as a February 30th. Okay.
February, it's only February 28th.
Okay, turn it into my equation.
Last time you.
Okay, good. Any questions?
No,
Oh, I already got the phone.
What's in February, at least?
No questions so far? Okay, so last page. All right, this is gonna at least seem more recent. Whether that's a good thing or a bad thing, I don't know. Sí, ella no sabe. I'll say.
Just always in the
No, well, no. No. Yeah. What type of a function is this? What type of a function is this?
And it's wait, I know it's not tiny square or something.
Well, it's gonna look like a parabola, but that's not the adjective that we use. Pretty much every it's a quadratic function, yeah. And more specifically than that, it's a quadratic function that is in which form? It's standard, so we can identify A, B, and C.
Are you taking the prime time on the first?
No.
How many essays have you had that are multiple choice?
10.
You've had 10 essays? Well, that's
Oh,
good.
wow.
Now, whether you choose to graph or fill in the table first, that's up to you. I've always done the table first. So let's see what we can answer based on just what we've identified so far. Is this going to face up or down?
Down.
It's the opposite of whatever time was. So this is going to go up. What's the domain going to be?
-0 to.
They're all real numbers, negative infinity to positive infinity.
Oh, yeah, I didn't.
Range is dependent on the vertex, which we don't know yet, but we do know it's going up. So we know the positive infinity part. We just don't know what the minimum is going to be, but we do know it's going to have a minimum. Don't know the axis of symmetry. Y-intercept I do know. Where's the y-intercept going to be? 30, which is not going to really help me on my graph because this graph is pre-printed for me, and I can't fit 30 in there.
H and K?
Well, I'm glad you asked. We're not going to change it to H and K, but we are going to have to find H and K because they're asking us for the vertex. So what's the formula for H?
It is B over 2 something.
B squared over 2.
Oh, dear. And this will not be up to yes, ma'am. It's up because A is positive, and when a parabola goes up, anytime you use the word minimum or maximum, you're referring to the vertex. Then it wouldn't be a parabola. Then it wouldn't be a function. Parabolas actually can face left or right, but they wouldn't be a function. In Algebra 1, we only deal with parabolas that are functions.
Oh, yeah, because if it's going sideways, then yeah.
Well, it would fail a vertical line test.
Yeah, exactly.
Did that answer your question or no? If it goes up, when you talk about minimum or maximum, you're talking about the vertex. You're talking about where it changes direction. So if it's facing up, it's going to change direction on the bottom, minimum. If the parabola is going down, it's going to change direction at the top. So it's a maximum. So now let's try again. This will not be on the test for you. So what is the formula for finding H?
No, B squared over 2.
Negative B over 4.
Negative B over 2A. So negative 16 over 2 times 2. It's a good thing that this is recent, because if not, you'd really be confused. Negative 16 over 2 times 2 is going to be negative 4. If I am, not that you even have to, but if you're completing this in real time and you wanted to fill in this table as we go, just by knowing that H, I now know my axis of symmetry is going to be at x equals negative 4. I also know the x of the vertex is going to be at negative 4. How you find the k is up to you. You could get that negative 4 and substitute it into the function. You can evaluate the function at negative 4. Or I showed you that neat, nifty thing that all the cool kids are doing. The other day I walked down the street and I saw some kids doing synthetic substitution.
Wow, dude.
And they had a lot of friends, so.
I don't like this method because I'm going to try to.
It did. You just did it wrong.
We went
No,
through
you really
every
did.
step, bro.
Drop the 2, multiply times negative 4, negative 8. Add, you bring me whatever problem you were doing and I'll show you how you were wrong. So add 8, multiply negative 32. 30 minus 32 is negative 2. So k is negative 2. But if you want to do it the long way, as Lumiere said, be my guest. So the range then would be negative 2 to positive infinity, and the vertex is at negative 4, negative 2. That's what's up. All right, so now let's graph. My axis of symmetry is going to be at x is equal to -4. And my vertex is going to be at -4, -2. Sometimes you have the benefit of being able to also use the y-intercept. But Amici's very mad right now because she can't. Very, very mad. Yeah. So we're going to have to use that other method, which I thought was pretty convenient, but yes, as Hope said earlier, requires paying of attention. Attention must be paid. I would like to find some lateral points. The word lateral means on the side. Okay. So I could find out what's going to happen one away from the vertex, whether I go up or down, which actually I already know so far that I'm going up. I would like to know what's going to go 2 away, or 3 away, or 4 away, or 5 away. It doesn't matter left or right, or 6 away. But understanding that the further away I go, the bigger my graph gets. For instance, I already have an idea of that because look, how far away is the y-axis from the vertex? It's 4 units away. And if you look, from what I've already found, just by going 4 units to the right or the left for that matter, it would be the same thing if I went left. Look at that. I'd have to go 32 units up. Me no likey. I'd rather keep my graph small. So let's keep things simple and let's just see what's going to happen. 1 unit away and 2 units away. First thing you got to do is square these numbers. What's 1 squared? What's 2 squared? But there is a second thing you have to do. You also have to multiply times A. A is what decides whether you go up or down, and that's what we're looking for now, is whether we're going up or down. So times 2, which is 2, times 2, which is 8. So the only last thing that you could possibly be confused of is because when you're used to counting points, you're used to counting from the origin, but we're not going to count from the origin, we're going to count from the vertex. So the first number that I put in there tells me how far to go left or right. What I ended up with tells me whether to go up or down. Since it's positive, I'm going to go up. So if I go 1 to the left or 1 to the right, I must go 2 up. If I go 2 to the left or 2 to the right, I must go 8 up. Use your fingers, have a finger party. Count up a storm. And there's your happy face.
I even did the dotted line.
That's not dotted, it's that.
Taiwan is full of sass today. He's awfully sassy. Okay, and finally, the last skill you would want to be aware of headed into your performance final is how to solve quadratic equations. I had the nerve to ask my first period what were the 4 different methods we've learned to solve quadratic equations, and it took like a full 10 minutes to get an answer, so might as well do the same thing here. What were the 4 different methods we learned not too long ago, it was about, 3 weeks ago, on how to solve quadratic equations? Completing the square, good. You would think 2 of them would be even easier to answer because they're like literally written on the board right now. Factoring, quadratic formula, that's 3, and then the one that took them the longest also.
Factory.
No.
Have you already said that? On the way. Don't find out.
I need to find shit. I don't know.
Quadratic equation.
Wait, what did we already say?
Reset
We said factory.
Completing the square. Square root property, very good. That is number 4. Take that, Jonathan.
Yeah.
You're way faster and way smarter than your first.
At least faster. All right, so In this particular practice problem, you are being told specifically which methods to use, quadratic formula and factoring. And the reason why you're probably being told to do that is because both of those methods, Jono, require you to make the equation equal to 0, which is already done for you. Another thing that both of those methods have in common is when you have three terms, they ask you to identify A, B, and C. Which on the first one, A is 1, B is 1, C is negative 6. Here, A is 1, B is negative 3, C is negative 5. But this specifically tells you that you have to use quadratic formula on one and factoring on the other. So the thing is, part of this is understanding that quadratic formula can be used to solve any quadratic equation. There is no quadratic equation that quadratic formula cannot solve. But factoring is limited. Factoring only works on certain ones. If you want a more specific reason, it's because factoring only works when the solutions are rational. But maybe a more elementary explanation would be that in order for factoring to work, remember when we did the table, the equal factor chart? When you multiply A times C, which in this case A is 1, so it's really just C. You have to be able to find two numbers that multiply to give you C, but also add up to B. And in these two particular problems, that can only be done with one of these. On these equations, there's only one of them where the factors of C add up to B. Which one would that be?
That would be the second one. I don't know. First one.
Can you think of two numbers that multiply to give you negative 5 and add up to 3? Well, geez, the only numbers I can think of that multiply to give you 5 are 1 and 5. And if it has to be negative, if it has to multiply to a negative 5, one of them has to be negative. But regardless of which one I make negative, there's no way to get that to add up to 3. So guess what? That's going to have to be the quadratic formula one, which would mean that the first one would have to be the factoring one. But okay, now I need to think of, and it shouldn't be, I would hope it's not too hard, think of two numbers that multiply to give me negative 6, but add up to positive 1. Two numerals multiply to give me negative 6, add up to positive 1. Good. Positive 3 and negative 2. And it has to be exactly like that with the signs. Thought the 5 was negative. Oh, sorry, did I erase the negative by mistake? Still can be done. Yeah, make sure the 2 has to be negative, the 3 has to be positive, because when you add them, you have to get a positive 1. So the bigger number has to be positive. Since A is 1, you can go straight to factor form, and then we use zero product property to make each factor equal to 0. X minus 2 equals 0, x plus 3 equals 0. So x is equal to 2, and x is equal to negative 3. But if you want to get the full allotment of points, you have to explain how you found your answers, which to me, the how part is the work. So, I mean, you've taken, as far as I'm concerned, you've taken care of how by showing me work, but the why requires a narrative. You have to be able to explain using words. So why did I choose factoring for this one? Yeah, well, no, you have to know what you're saying, not just, yeah.
Because I used the and that was the only one that I could use factor for.
Yeah, I know, but that's not saying much. I get it. You are right. This is the only one you could use factoring for, but that doesn't tell me why. I actually already told you why, but can you repeat what I said?
Yes, because
the easiest way to explain it, even if you probably don't know what it means, even though you should, this is actually something you should have learned at the very beginning of the year, which is the solutions are rational. And wait, you know what? Let me be clear. I don't have a lot of space here, so So remember, this is supposed to be in the form of a narrative. So you would say, I chose factoring for the first one because the solutions ended up being rational. That could explain why factoring works. I wouldn't accept that. But if you wanted to do like a more bare bones type of explanation, you would say that again, you would start off by saying I chose factoring because this was the only one where the factors of AC added up to be wait there. And then finally on the last one, now we can't use this as justification. You can't just say, well, because I already used factoring, now I have to use quadratic formula. But that is indeed what we're going to do. We're just going to have to explain it better at the end. We could say, now look, this is written here, and I'm going to provide you with a reference sheet anyways, so you'll know quadratic formula if you haven't memorized it by now. But if b is -3, then I would write +3 plus or minus the square root of -3 squared minus 4 times 1 times -5 over 2 times 1. Make sure that you change this. This will cause you to lose points. Make sure that the first time that you write the 3 is positive. Now, what is -3 squared? What is -3 squared? It's +9. How many negatives come after the square? 2. So that changes to a plus. And 4 times 1 times 5 is 20 over 2. How about if I just wait several seconds? You give me the cue when you're ready. You say, and action.
Cute. Action.
3 plus or minus square root of 29 over 2, which might seem like a bummer. Because you're like, whoa, Mr. Romero, 29 is not perfect. And besides not being perfect, it's also prime. But since you guys like less work, that's a good thing for you, because when that number, by the way, what's that number called?
No.
It starts with D and ends with discriminant. Yeah. When the discriminant is prime, you can't do the square root, you can't do the plus or minus, you can't do the division, so we're actually done. By the way, before I forget, here's another, this requires more work on your part, but if you want to make sure you got it right, speaking of the discriminant, you can actually use the discriminant also for this first part of deciding which method to use. If you do a discriminant, and that discriminant, which is the b squared minus 4ac, right? Because I could use that for either one, right? I've identified b squared minus 4ac for either one. If that discriminant ends up, in order to be able to use factoring, that discriminant has to be both positive. Well, I guess technically it could be 0, but let's just keep it simple. Positive, but the more important thing is it has to be a perfect square. Watch. Did I do a discriminant for the first one? No, I didn't. I did factoring. I never bothered to touch it, but let's just say I would have, right? The b was 1. So 1 squared minus 4 times 1 times -6. 1 squared is 1. How many negatives come afterwards? 2, so 4 times 1 times 6 is 24. That gives me 25. 25 is not only positive, it's also perfect. What's the square root of 25? 5. If you get a discriminant that is both positive and perfect, you can use factoring. Anything else? Any other discriminant? Negative, not perfect, positive, 0. Even though 0 sometimes could work with factoring, but it would be a special case for factoring. Any other discriminant would be quadratic formula. So, but now we do have to write a narrative. You know why? And look, now that we've introduced this, you could even add that as another justification. You could say the discriminant was both positive and perfect. You can use that as a reasoning for factoring. Huh? Do I have to write a narrative? Yes. That's why the performance exam is the closest thing you'll get to an essay in math. So, what are some possible reasons for using this? You could say the solutions were irrational, because that's what it's called when the square root is still there. Are irrational. That would be for the second one. You could say the discriminant was not perfect. That could be another reason. What's the discriminant, Elsie?
But it's not perfect.
You're not listening, Morgan.
No,
I can tell. It's the patented LC blank stare. The discriminant is b squared minus 4ac. Or the last thing you could say is the factors of AC could not add up to B. That would be. So I just gave you 3 justifications for each one, of which I would take any of them.
Oh, okay.
No, you don't have to write all of them unless your name starts with an E. And then you have a middle name that starts with a G.
No, I'm not
Lies.
Why do you not believe me?
It's Gertrude. Elizabeth Gertrude.
I mean, that's supposed to be great.
Elizabeth Guinevere.
Close with people.
Alright.